Welcome to the project demonstration of 4-quadrant operation of DC motor using PIC microcontroller with speed monitoring on LCD. So we are controlling a DC motor in 4-quadrant mode, that is forward, backward motion, along with speed increase decrease in respective direction, and forward braking and reverse braking. So totally 6 operations, as we know that 4-quadrant operation consists of, and that will be done with the help of these 6 buttons and getting input to the microcontroller. We are using PIC HVS-3153 microcontroller. Based on the selection switch, system will control the speed, direction, braking by using L298 motor driver, and the status of this one is displayed continuously on the LCD screen, and the whole system getting power supply from this 230 volts AC input to the transformer, which will step down the 230 volts AC to 12 volts of AC, and the 12 volts of AC is input to the regulated power supply board, so which will convert 12 volts of AC to 5 volts of DC using 3 stages: rectifier, filter, regulation. So rectifier to convert the AC to pulsating DC, filter to remove the pulses and make the pure DC, and regulator will provide us the 5 volts constant DC. Once we provide the 5 volts DC input to the microcontroller, it start reading input from the switches initially. Then after, based on the switch inputs, it will trigger the motor in the respective direction, the selection switch, and increase the speed, decrease the speed. And in the closed loop manner, we are going to measure the speed of this DC motor with the help of this IR sensor, which was interfaced at the pin number A4. So here we 6 buttons interfaced at A0, A1, A2, A3, C0, C1, and this LCD display pin number B2 to B7, C6, C7 for the L298, along with the C2 to PWM of a DC motor to control the speed. So these are the main input connections in our project. So here let us see the demonstration. So once we on the gauge, so we need to set the IR sensor sensitivity, right? So the problem is with sunlight, whenever the external sunlight is falling on the IR sensor, then the continuous light will be on. So now we need to check initially, when you rotate this shaft of this DC motor, then only the light should get switched on based on this rotation of this motor. So that we need to set, that's why we block the external sunlight from the sun by using this thermocol. And now just we need to select the forward or backward. So it's forward backward direction, speed up, speed down, forward braking, reverse braking. So the forward is selected, so now only the forward braking will be done, right? Okay, and now in reverse, hold the switch till we get the operation execution. So now this forward braking won't be done, as you can see the light indication on this motherboard, but it won't be executed as it's rotated in the reverse direction. Right, now it is stop. Again forward and increase the speed. Just hold the switch. Again see the speed increment on this LCD display. So for every input we can see the light blinking on this motherboard. Here we can see that, and here also we can see the blinking rate on this IR sensor, as it is indicating the getting pulse input from the DC motor rotation. Now let us decrease the speed. You see the speed is slowly decreasing. Right. So as of now it's rotating in forward, braking only enabled, so that's why it's not working. Right, now it is brake applied and reverse braking also. Same. So in this manner we have achieved the 4-quadrant DC motor operations, that's forward motion, backward rotation, and speed increasing, decreasing in forward and reverse, as well as forward braking and reverse braking. Thank you.